All right, so we are doing the last two parts of 8.3. So 8.3, D through E of polynomials, linear factors, and zeros. To get us started on part D, we're going to talk about what's called multiplicity, okay? When you hear the word multiplicity, you should think the word multiple, right? Like more than one, okay? When a linear factor occurs multiple times in the factorization of a polynomial, that gives the related zero multiplicity. So what that is saying is if I had x minus 3 times x minus 3 times x minus 3, that the x minus 3 appears multiple times, right? So it can be condensed down to x minus 3 to the third. Does that make sense? So it has a multiplicity of 3 because how many times was it repeated? 3 times. Cool? Okay. The multiplicity of a zero is important because it tells us how the graph of the polynomial will behave around the zero, okay? A function will have either have an even or odd multiplicity, okay? It will have either an odd or even or odd multiplicity. So let's first start with our even multiplicity, okay? So example of even multiplicity is that the factor is either to the second power, the fourth power, the sixth power, but the factor is to an, yeah, to an even power, right? Okay, so here it says, notice the function right here. We have f of x equals x minus 1 times x minus 4 squared. So this is a even, okay? If you look here at our zeros, it behaves differently around x equals 0 and x equals 4, okay? At x equals 4, you can see right here how it touches the x-axis. It doesn't cross the x-axis, it touches the x-axis. And that's because we have a double zero. We have an even multiplicity. Okay, we have an even multiplicity. And so what I call this is when it's even, it kisses the line. It's gonna just touch the line. So it's gonna kiss the line. So if it said x minus 4 to the 4th, it's gonna kiss the line. If it said x minus 4 to the 6th, it's going to kiss the line. Now, notice here at x equals 1, the factor was x minus 1. If there's no number there, what is the power of that binomial? 1. And 1 is what? 1 is odd, right? So it has an odd multiplicity. When there's an odd multiplicity, it's going to cross the x-axis. That's why most of ours have been crossing, because they've been odd multiplicities. There's only been one of that factor. Okay, so then let's look here. Example of an odd multiplicity. So if I had x minus c to the 3rd, or x minus c just as a 1, or x minus c to the 5th, if we look at this function g of x, it's x minus 1 squared times x minus 4. Okay, at x minus 1 now, at x equals 1 now, we have a double. It's double. It's an even multiplicity. And so notice that it touches the x-axis. It doesn't cross, it touches. At x equals 4 now, we have an odd multiplicity. It's an odd multiplicity because it crosses the x-axis. And again, what is the power of this binomial? 1. All right. So even multiplicities are going to touch. Odd multiplicities are going to cross. Do we see that? Even touches, odd crosses. Okay. So here's our first example. We have, what is the factored form of, that's the first thing we're going to do, of f of x equals x to the 4th minus 2x third minus 8x squared. So the first thing we're going to do is factor. So when we talked about factoring this week, the first thing you want to look for is a GCF. So if I have x minus 4, 2x to the 3rd, and 8x squared, what is their GCF? The GCF is x squared, right? They all have at least 2 x's. So I'm going to factor out x squared, and I'm left with x squared minus 2x minus 8. Then I'm going to factor the trinomial using any of the methods that we've learned. The easiest one here is our mental. What multiplies to give me negative 8, but adds to give me negative 2? What are my magic numbers? Negative 4 and positive 2. So this is me fully factored. So this is f of x equals x squared times x minus 4 times x plus 2. So step 2, finding my zeros. So my zeros here are taking each factor and set them equal to 0, which is what you should have been doing on your math activity, right? So I have x squared equals 0. I have x minus 4 equals 0. I have x plus 2 equals 0. So that gives me x equals 0, x equals 4, and x equals negative 2. So we have x equals 0, x equals 0, x equals 4, and x equals negative 2. Step 3 is to identify the multiplicity. So how many times are they? Is it an even or odd multiplicity? So x equals 0, its factor was to the second power. So at x equals 0, what type of multiplicity is that? It's an even multiplicity, right? Because it is twice. That 0 counts twice. At x minus 4, its multiplicity is just 1. So it's a odd multiplicity of 1. At x plus 2, its multiplicity is just 1. So it's an odd multiplicity of just 1. What the multiplicity tells me is what is going to happen at the graph. So if I have an even 2, that means I'm going to touch the graph. I have an odd 1, I'm going to cross. Odd 1, so I'm going to cross. So it tells me my behaviors at the graph. So graphing this, looking here, I have a even polynomial, an even positive polynomial. So I know that it's going to be up and up, right? I'm going to begin and start in the positive. So if I start, I'm going to come down. So at x equals negative 2, I cross. At x equals 0, I touch. And at x equals 4, I cross. Isn't that the other way? Okay. Now we're not focused on what the y values are. We're just focused on what shape, or ideally what shape I'm looking at. Okay. If we wanted a more accurate graph, we talked about that earlier this week in previous videos, that you would plug in values between the x-intercepts to know how much further you would need to go down to get a more accurate graph. But it's asking us what's happening around our zeros. How do you feel? So do you see just added on a little extra to what we've been doing all week if you've been keeping up and doing your work? Okay, let's try another one. So here we have, what is the factored form of f of x equals x to the third minus 4x squared plus 4x. What are the zeros? What are the multiplicities of the zeros? And how does the graph behave at these zeros? Okay, so the first thing we're going to do is factor. So what's their GCF? It's just x. So I factor out x. And I'm left with x times x squared minus 4x plus 4. This is a simple mental factor. What multiplies to give me 4, but adds to give me negative 4? It's negative 2 and negative 2, right? So we have f of x equals, and I can condense this down to f of x equals x times x minus 2 squared. So next it says, what are your zeros? So my zeros, I have x equals 0. I have x minus 2 squared equals 0. So that means x equals 2. What are the multiplicities? So my multiplicities. At x equals 0, it's just one time, right? So it's an odd multiplicity of 1. At x equals 2, how many x minus 2's did we have? We had 2. So it's an even multiplicity of 2. So what that means is that at 1, we're going to cross, and at 2, we're going to touch. So we have 0. It's a what? It's a what? There we go. It's an odd positive, right? So odd positive means I'm going to start negative, but end positive. So I'm going to start negative. At 0, I'm going to cross. Do we see that? That's a horrible crossing, but pretend that's straight. But at 2, I am touching. So I cross at 0, I touch at 2. All right, questions about multiplicity. So summarizing multiplicity. Odd multiplicities do what? Cross. Even multiplicities do what? Touch. Got it? Odd cross, even touches.